Hello and welcome back to another virtual lesson here in Mr. Spencer's virtual classroom. I do just want to let you know we are back to filming the video tonight at night. So I'm sorry about the funky lighting. It is dark out. We don't have a screen behind us today, so it would mess with the light. But thanks for being here. I'm glad you're here, even if you're not watching this at night. Whether you're watching it morning, afternoon, one of the things I love about our virtual learning is that we can do it at the time that's best for us. That being said, today we're going to continue talking about types of measurement. I'm hoping today goes really quickly. I think it should. Not only do I want to go to bed tonight, but you all also rocked what we have been doing with area, areas of triangles and squares as well as funky shapes. So I'm sure you will do awesome today. I did get some questions about area, of funky shapes. Got some appointments scheduled, answer some questions via email, text, and video chat. So please continue to reach out if you need anything. My office hours are on the Schoology page, or you can email, text me to schedule something outside of that. Anyway, today we're going to talk about measurements. We're going to talk about the three different dimensions. The first dimension, one-dimensional, is going to be distance. How far it is from point A to point B. Think of a line. Two-dimensional, guess what? That's what we've already been talking about this past week, is going to be area. Area is going to be the whole thing, which is going to be the top of something. And then three-dimensional, we get into what's called volume. You may have heard of this before, but we're going to start right there. Volume. So that's going to be the entire shape. Think of it as the amount of water in a cup, or the amount that you could put in a box. The volume is going to be what's on the inside. So I'm going to say inside a cup or box. And volume is the amount of space on the inside of a three-dimensional object. As always, if I go too fast for you, feel free to pause this video. I know I go fast, and I want to make sure you have plenty of time to read this, comprehend it, think it, write it, if that's what you're doing. Specifically today, we're not going to talk about anything that's rounded. We are only going to talk about prisms. Prisms are three-dimensional, so it has length, width, and height. Got three sides to it. Three-dimensional shapes with two parallel bases and rectangles for sides. So obviously the biggest thing, most common prism, is going to be a box. It has a flat top, a flat bottom, and all rectangles for sides. But they can happen with any sort of shape. When you have a polygon as a top and a polygon as a bottom, and they are parallel to each other. Think of a block of cheese, a nice little wedge of cheese. Pretend this triangle is filled in. I'm not the best with crafts, and I had no cheese downstairs. At the top, there's a top and a bottom that are both not curved, and then each of the three sides is going to be a rectangle. So that makes it a prism. But you can have all sorts of different shapes. There are no curves. If there are curves in it, this is going to be called a cylinder. So a cup of water would be a cylinder because it's curved. You got this big, that still has water in it. You have a round top and a round bottom. Hold on, I got something here. A round top and a round bottom, and then there are no rectangles on the sides because it is curved all the way around. So that's what a cylinder is. All right, so we're going to start with our formula. It is super simple. It is your base times the height. That's it. I will say this base is not the same base as this triangle. This base is the area of the top or the bottom. And of course, with our prism, the top and the bottom are going to have the same area. They're the same size. So our formula is just base times height. All right, so let's take, I'll draw a box because my box is a little too big for us to fit on that camera. Here's our box. This is going to be our base here, and this is going to be how tall it is. So let's say this is 4 times 3 times, let's call this 2, just so we have all different numbers. We're going to find our base, which is the area, is going to be the length times the width, which will be, substituting those in, 3 times 4 equals 12. And then h is going to be the height, is going to be this 2 right there. Now, my drawing may look a little funny because it looks like you think the height is how tall it is, but ultimately in a rectangle, any side can be the base because they are all parallel to each other and each of the sides is a rectangle. When we draw our triangular prism, it'll look a little bit differently, look a little different, and there'll be a very distinct base versus the height. So our formula is going to be base times height, which is 12 times 2. And that equals 24. Now, you notice I didn't put in a unit here. We remember that we always have to have a unit when we're dealing with area. It's the same thing with volume. So we're going to put in meters. It's a big rectangular prism, I know. Just going to bear with me. So if our units are all meters, this is going to be 24 meters is the volume. Now, I'm going to jump back to where we were over here. You saw how, remember in area, how we had a number, we had the units squared with that little 2 up there? Look at that, it's the second dimension. We didn't need the 1 for the first dimension, but you could, because that 1 just means we're in a 1 dimension. And then look at that. So when we're in the 3rd dimension doing volume, we're going to have it be to the 3rd power or cubed. Now you see now that cubed is a shape, a 3-dimensional shape, as opposed to squared would be a square, whereas the first dimension is just going to be a line. So that's why we have the 2 that makes a square and 3 that makes a cube. If we were actually in class, we'd pull out some blocks and stack some things together, so you could calculate the area that way. I'll see if I can find a video to post in the next couple of days where you can try it at home. But for right now, just know that we put the 3 there because we're counting the number of cubes within any sort of 3-dimensional object. So back to this page, we have our base, which is the area of the base, times the height, which was 2. We get to 24 meters. Now, if we're going to expand this, you can expand it using the formula for your base area. That's just where we put everything together. So we had it separated into two parts. We had the length times the width that equaled the base. And then we had the base times the height. We're just going to put all of this in for B. So we're going to put all of that in for B down there. So we're just going to do the length times the width times the height. So you have the length times the width times the height. And this is only for a rectangular prism. Alright, and that's because the length times the width right here is the base area. So we're going to try this with a triangle now. And I'm going to try and pick some friendly numbers. I forgot to plan this one out. So we have our formula. That's the same for any prism. Is our base, which is the base area, times the height. Now I'm going to draw our triangular prism. We're going to have a triangle. There's our triangular prism. If you are a better artist than me, and you probably are, hopefully yours looks better. I'm super sorry. So we have two measurements on the triangle front. We have the height, which is going to be 6, and the base here, which is going to be 4. We're going to use meters again. And then this is a pretty long triangle, so we're going to use the height of 10. Now, remember how we said it's the height even though it's that it looks like it's laying down? That's because you could easily turn this on its end, and then you'd have the same triangle. You'd have a measurement there of 6, this one of 4, and then the height of 10. So you remember our formula for the area of the triangle, so we have to solve that first. Base is going to be 1/2 the base times the height. Now this base is going to be the triangle formula. And then we're going to also have the height. And we know the height is just 10. So we can go ahead and solve for B down here, putting in our numbers. We have 1/2 times our base of 4 times our height of 6. Okay, and I know 1/2 of 4 is 2, then 2 times 6 equals 12. And then we have H is, as we know it, 10. So then we put that down into our equation down here. Oh, I'm so sorry, I ran off the page. We have B times H. Just gonna put this in for H. This substituted in for B. So I'm going to rewrite our equation as 12 times 10, and solving that out equals 120. Our unit is meters. We make that meters cubes. To label one of those up there with a meter. Forgot to label that up there. So the volume, the amount of space in that triangular prism up here is 120 meters cubed. So that's it. That's how we find the volume of prisms. There's going to be some practice on IXL. It should just be rectangles and triangles. If it's anything funky at all, let me know, and I can help you with it. But other than that, awesome job. Reach out to me with any questions, and you are doing great things. Goodbye.